are still in Chapter 10. This is Section 6, using segments of chords, tangents, and secants. So we need to know when two chords intersect in the interior of a circle, each chord is divided into two segments, called the segments of the chords. So AB is a chord, AE is a segment of that chord, as well as EB. We have the segments of the chords theorem. If two chords intersect the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. As you're writing this down, think about what that means. Stop the video and restart when you're ready for the next problem. This problem says to find X. Well, if I'm looking at this, I see that I have two chords. One of my chords is KJ, and it has two parts. And the other chord is ML. It also has two parts. And so if I look at the theorem, NK times NJ is equal to NM times NL. When I use algebra that I learned last year, and I have to FOIL it and distribute, then I have to set each one equal to one another, and I see that the x squares are going to cancel out, giving me 4x equal 3x plus 2, and then I'm going to go ahead and solve for x. Now it's your turn. Look at this problem, write it down. When in doubt, always draw it out, and stop the video when you're ready to set it up and solve, and then restart again to see the answer. And when I reduce negative 12/8, it equals negative 3/2. All right, so now let's look at this. A tangent segment is a segment that is tangent to a circle at an endpoint. A secant segment is a segment that contains a chord of the circle and has exactly one endpoint outside the circle. The part of the secant segment that is outside the circle is called an external segment. We've had all of this before, except for the external segment part, but now we're going to put them together, and we're going to look at a new theorem. That theorem is called the segment of secants theorem. If two secants segments share the same endpoint outside a circle, then the product of the lengths of one of the secant segments and its external segment equals the product of the lengths of the other secant segment and its external segment. So it's kind of just like what we did, only this time it's two secant segments. Okay, let's look at this problem. Set it up. We have two secant segments with an external point on the outside. Stop the video and see if you can figure it out. So as I finished solving this, I noticed that the only answer that I can get that makes any sense is x equals 3, because negative 5/2 would be an extraneous solution. Now we have segments of secants and tangents theorem. If a secant and a tangent segment share an endpoint outside a circle, the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segments. Okay, now we have one last problem. This time we have a secant and a tangent segment. See if you can set it up and figure it out. Stop the recording and restart it when you're ready to find the answer.